This is a review of some exponential rules. First one is that x to the 0 is equal to 1, which means that any number to the 0 power is going to equal 1. Okay? And so, for example, if I put 7 to the 0 power, that's equal to 1. If I put 3 to the 0 power, that's equal to 1. Everything to the 0 power is equal to 1. Okay? Let me show you how that is justified. Here I made a string of base 3 to an exponent. Okay? And if you do this on your calculator, you can evaluate a lot of these. Some of you are going to know by heart, right? 3 to the first is just 3. 3 squared is 3 times 3, which is 9. 3 cubed is 9 times 3, which is 27. Okay? You may not remember this, but 3 to the negative 1 is actually 1/3. 3 to the negative 2 is 1 over 3 squared, which is 1 over 9. And 3 to the negative 3 is 1 over 3 cubed, which is 1 over 27. Okay? You may notice that this is a geometric sequence. Every time you multiply the previous number by 3, you get the next number. So 3 times 27 gives you 3 over 27, which is 1/9, right? Multiply by 3 again, and 1/9 times 3 is equal to 1/3. Okay, and then let's do these over here. 3 times 3 is equal to 1/9, so it continues being a geometric sequence. And then 9 times 3 is equal to 27, right? So there's a pattern there. So we can assume that if we wanted to continue this pattern here, we would multiply 1/3 by 3 and we would get 1. And the same thing, if we multiply by 1, we multiply by 3 and we get 3. So you see that we've completed the chain here. And we notice that the exponents also are going up by 1 every time. So do you see how we've kind of inferred that 3 to the 0 corresponds to a value of 1 by completing the geometric sequence here? Okay, so that's why 3 to the 0 or anything to the 0 equals 1, even though it doesn't really seem obvious. Okay? Let's go to the next rule. These are two different rules. One of them is the product rule, and one of these is the power rule, and they're really easily confused, especially when you use symbols like this. How can you remember that one of these is equal to x to the m plus n, and the other one is equal to x to the m times n? We never remember which one is which, right? So let's figure out a way that you can test it before you decide which one is which. Okay, so the way you can test it is you can put in numbers instead of the x and the m and the n. Once you put numbers in, it gets a lot easier. So first of all, I'm just going to put numbers in for the m and the n. Okay, I'll leave the x's, and then after that I'll put in actual numbers. Okay, so instead of x to the m and x to the n, I'm going to put x to the 2 times x to the 3. And then for the power one, instead of x to the m to the n, I'm going to put x to the 2 to the 3. Okay, this is usually enough to figure it out. If you have x squared times x cubed, that's the same thing as x times x times x times x times x. And then you're like, okay, if I multiply x times itself 5 times, that's the same as x to the exponent of 5. So you see that x squared times x cubed is equal to x to the 5th, which means, how do you get this number? You get it by adding the 2 to the 3. So if you have x to the m and x to the n, we've concluded that that is equal to the x to the m plus n, and we did it by putting numbers in for m and n. Okay? Now we'll do the power rule. For the power rule, x to the m to the n is not obviously one of these two. So we're going to substitute a number. So we'll put x2 for m and we'll put 3 for n. And then we're going to test this. So if we have x squared cubed, that's the same thing as x squared times x squared, right? which is the same thing as x times x times x times x times x times x, right? And then if you take out the parentheses, we're going to have x times itself 6 times, right? Which is equal to x to the 6th, right? So if you have x to the 6th, how would we get x to the 6th from 2 and 3? Well, you would multiply them together, right? So that means that x to the m to the mth is equal to x to the m times n. So we've kind of figured out the two rules just by putting in some numbers here, okay? And if you really don't like the x's, you could do something similar with just numbers, okay? So I could do 2 squared, 2 cubed, and I can't remember if 2 squared, 2 cubed is 2 to the 5th, adding them together, or if it's 2 to the 6th, multiplying them together, okay? I'm not sure which it is, so what I'm going to do is I'm going to do a test, and I'm going to say 2 squared is 2 times 2, 2 cubed is 2 times 2 times 2, and then if I take off the parentheses, I can see that that's actually 2 times itself 5 times. So I figured out that that is what it is, okay? And then for a 2 squared cubed, I can figure out that this is 2 to the 5th or 2 to the 6th by expanding this out. So 2 squared cubed is equal to 2 squared times 2 squared times 2 squared, which is equal to 2 times 2 times 2 times 2 times 2 times 2, which is equal to 2 times itself 6 times, which is 2 to the 6th. Okay? So, we have figured out, again, that 2 squared to the 3rd is equal to 2 to the 6th, and what I did to get that was I multiplied those two together. Okay? So those are just a couple different ways for you to test yourself, the situation. If you forgot that the product of two exponents is you add the exponents to get the 5, or the power rule says that you multiply the two exponents to get the exponent of the equivalent exponent, okay? So I'm going to show you another way to remember that later, but I'm trying to show you why it works, okay, and how you can do a test, a math test, to see which one is really the right one, okay? Now, let's talk about x to the negative 2. X to the negative 2 is the inverse of x squared, okay? And maybe this doesn't seem too obvious to you, and let's try to figure out a way to justify it, okay? So remember that if you have an exponent like 3 squared, okay, and I'm going to multiply it times something, and I'm going to get a 1, okay, what would be this number that I'm going to multiply by? Okay, so let's see. First of all, this might seem a little weird to bring up now, but remember that 1 is 3 to the 0. I'm going to write 3 to the 0 here instead of 1. Okay? Then I'm going to put 3 squared, and then I'm going to figure out what do I multiply times 3 squared to get 1? Well, 3 squared is 9, right? What do I multiply times 9 to get 1? I would multiply 1/9, right? Well, 9 times 1/9 is equal to 1. Okay. Now I'm going to represent this as an exponent of base 3, and I'm going to represent this as an exponent of base 3. Then I'm going to say I want to represent this too as an exponent of 3, but I don't know what the exponent is. Okay. So I have 3 squared times 3 to the something equals 3 to the 0. So remember that if I wanted to figure out how to relate this, this, and this, I could use the product rule, right? The product rule says I can multiply this number and this number together, and then it gives me this number. I'm sorry, I can add these two together, and it gives me this number. Let's go back and look at it again. Here's the product rule. 2 squared times 2 cubed is equal to the 5th. So 3 squared times 3 to the something equals 3 to the 0. So I can take 2, add it to something, and it equals 0. This, of course, is negative 2, right? Okay, so we've just shown that if we have 3 squared times 3 to the something equals 3 to the 0, then we know that the something has to be negative 2, because 2 minus 2 is equal to 0. Okay, so we've also just shown that 3 to the negative 2 is 1/9. 3 to the negative 2 equals 1/9, which means that 3 to the negative 2 is equal to 1 over 3 squared. Okay? So a negative exponent means you invert it, basically. Okay. One last definition. X to the half. X to the half turns out to be the square root of x. Okay? And let me show you why that's true. If I have x to the half, and I multiply it times x to the half, okay, then the result should be, using the product rule, 1/2 plus 1/2 is 1. So that would be equal to x to the first. Okay? Now let me put some numbers in here. I'm going to put 7 to the half times 7 to the half equals 7. Right? Okay. Do you notice that these two numbers are the same? If I have two of the same number multiplied times each other to get a 7, what is the value of the unknown number? Well, of course, it's the square root of 7, right? So that means that 7 to the half is actually square root of 7. Okay? So x to the 1/2 is actually saying square root of x. And later, you can also see that if you have x to the 1/3, it's equal to the cube root of x. And if you have x to the 1/4, it's equal to the 4th root of x. Okay? So in summary, let's go over all the rules. Okay. One of the rules is that if I have a number to an exponent multiplied times the same base and another exponent, I can add these two exponents together. 5, 2 plus 3 equals 5 to the 5th, right? Another rule tells me if I have 5 squared to the 3rd, then I can multiply these two exponents together. 5, 2 times 3 equals 5 to the 6th. Okay. Another rule tells me that 5 to the negative 2 is actually equal to 1 over 5 squared. And the last rule tells me if I have 5 to the 1/2, that is equal to the square root of 5. Okay? Or if I have 5 to the 1/8 or something weird, it's the 8th root of 5. Okay? Now I'm going to show you the last thing, which maybe helps you with these two rules. Okay. This chart here might be able to help you figure out when you're supposed to use each kind of operation to combine exponents. Okay. First of all, let's look at these inverse function pairs. So on the left side we have power, on the right side we have root. Remember, root is like the square root. Okay. That's the opposite of squaring. Square root is the opposite of square. Second row we have multiplication is the opposite of division, and then the third row we have addition is the opposite of subtraction. Okay? Basically what you're going to do with this is every time you see power, you're going to think, okay, that's going to be multiplication. Every time you see multiplication, you say, okay, that's going to become add, and so on. Okay? And let's show you how that works. It may not make much sense yet. Okay? What that means is if I have two exponents, like x squared, x cubed, and I am multiplying them together, then it's like, okay, how do I get my exponent for this? Well, I look at the chart, and since I am multiplying the two exponents together, that means that to combine them, I'm going to add the exponent. So it's going to be 2 plus 3 is 5. Okay? What if I had two exponents and I was dividing them like that? How would I reduce that into a single exponent? Well, since I'm dividing, then I would go down to the next level, which is I would subtract the exponent. So it would be 3 minus 2. Okay? Last of all, what if I was multiplying the exponent times a root? Okay, how do I do that? Okay, so a root, if I go down one level, it's division. So I would divide the exponent. So I would say x to the 3 halves. Okay, so basically the way it works is I look to see what operation I'm doing between the exponent expressions, and when I want to convert that into a single exponent like I do here, I look at the chart, I look one level lower, and then I use the operation that's one level lower to combine the exponents. So for example here, I am multiplying the exponents, so when I combine the exponents, I'm going to use addition. Okay? And here, I am taking the power of exponents. So if I want to combine those exponents, I go down one level and I do multiplication of the exponents. And if I am doing division of exponential expressions, then I look at the chart, and one level below division is subtraction, so I subtract the exponents. And last of all, I don't think you're going to use it as much, but if I am taking the root, then I am going to look one level lower, and then I'm going to do divide. So for example, if I have an exponent here, and then I have a root multiplied times it, then I am going to divide the first exponent by the root. Okay? So that might be an easier way for you to remember it if you want.